help people in general become more agile. We also have a series of training classes in these areas, as well as what it mentioned, Selenified, which is one of our 2 open source products that we support. And we're also very active in the software community. We own a series of software development, agile DevOps and testing conferences through our brand TechWell, and also have a set of online free communities. So if you're interested in agile or DevOps or in testing, we have agileconnection.com and stickyminds.com. They are free environments and online communities for software professionals, as well as a new Slack-based community called the Hub, hub.techwell.com. It's a free Slack-based community as well. What I'm going to talk about today is testing in DevOps, and then we're going to drill specifically into Selenified and LambdaTest and how they work in that environment, and answer any of the questions you have about those products and how testing works in a DevOps world. So the first question I always get whenever I say testing in DevOps is people say, well, what is DevOps? Right? Well, I'll start by telling you what it's not. It's not dev and ops, all right? I always tell senior executives that the term DevOps, really think of it as bookends for a bookshelf. You have dev on one side, and that includes the business and all the thinking up front about what you're going to build. And then you have the operation of what ultimately gets built. But they're really just bookends, because in the middle, there's all this stuff, right? And there's a lot of things that aren't software assurance or testing related, but there are a lot of things that are testing related too. And in general, in DevOps, we're calling that continuous testing. So it's how do we effectively test during an entire continuous DevOps process to make sure that everything from functional quality to non-functional types of aspects of quality and security are integrated in. And so think of it more like a bookshelf, with dev and ops being the bookends, and all sorts of activities between those 2 things that are also incorporated in those terms. And the things that are assurance related, that's what we're calling continuous testing. So a little bit of a definition about continuous testing. So I define it as the practice of testing across the entire life cycle, with the goal, of course, to rapidly uncover and fix unexpected problems, but also to provide the organization information to make good business decisions. Because after all, as testers, our job isn't just to find the bugs. Our job is to give the business information so that they can decide whether software is ready for release, what the risks are for that software, and things like that. And continuous testing is all about doing that across the entire life cycle. And I'm going to talk in this webinar up front a little bit about the different aspects of that, because I have spent a lot of time digging into continuous testing and what it means, and kind of have formulated my own opinions about how it fits and how it all works together. So let's talk about some of those, I call them key aspects of continuous testing. So we're all familiar, of course, with this infinity sign that a lot of people use to describe the DevOps process, and the whole purpose of showing it like it's shown is really to emphasize the fact that this is a constant, nonstop, continuous process, right? We discover new capabilities that we're interested in implementing for our customers to add value. We design those capabilities. We implement those capabilities in code. We test and deploy those applications to our customers. We operate, manage, and maintain that software in its production environment. And through that process, we gain feedback about what customers want, what they don't want, what they need. And that feeds back into the discovery process. So we can go around and around and around in this loop. Now, some people are doing this thing extremely fast these days. You probably read about continuous deployment and the idea that every time you make a change code, that change propagates all the way through and goes into production. There are certainly organizations that are doing that, but there's also a lot of organizations, for a whole variety of reasons, that aren't moving that fast, but are still gaining and giving their customers a lot of business value. So they're still following this infinity sign, if you will. It might just not be a day-to-day cycle around this particular loop. So I'm going to use this infinity sign as kind of a way to describe and depict the various aspects of continuous testing and what they mean to me. So the first aspect is the word continuous. It's in the title, right? If we're talking about continuous testing, we need to talk about the word continuous. And what that means to me is that instead of thinking about testing as a phase in the life cycle, right, like we did traditionally in a waterfall kind of model, we're now thinking about testing during the entire process. We're thinking about it before, during, and after we build code. And we're thinking about testing things other than code, right? We're thinking about testing our tests. We're thinking about testing our delivery scripts. We're thinking about testing our design, our requirements. We are evaluating and assessing the quality of everything that we do in the entire process, right? And we're going to talk a little bit about continuous integration and continuous delivery. And I'm going to at least show you a simple demo of a pipeline and how testing fits into it a little later. But if you think about that, continuous integration, which is this idea of constantly testing as we go. In fact, every time we make a change, we're providing and performing testing, irrespective of whether we're delivering or deploying that particular change directly into production. That's an example of a type of testing that we're doing continuously in our process. There's others examples as well, right? Instead of thinking of testing as something after the software is done, again, we're thinking about it as something that happens before and after and during. And so unit testing and testing at lower levels in our application before it's completely built in an incremental model like this is something we're going to expect to do. And that's all part of thinking about testing in a more continuous way. We're going to talk about how compatibility testing fits into that when we get to Selenified and LambdaTest. The second aspect is what I call shift left. There, I got my automation. Shift left is about moving some testing activities that have traditionally been late in the life cycle to earlier in the life cycle in this infinity loop. And good examples of that are our non-functional requirements. Things like performance and security, accessibility, compatibility have often been things that we did extremely late in the life cycle because our thought process was we needed an entire system to be able to do them successfully. And what people have realized, and the challenge with that in a DevOps model, is that one provides a huge hurdle to deployment, right? Because now we have to do all these activities. We have to wait until the software is completely implemented in order to do that. And that adds a lot of time at the end of our loop, our process, our deployment process, and that slows this whole infinity symbol down, right? And so the idea of shift left is, can we do those activities earlier? Can we do them incrementally as we go? Can we somehow shift into the development process some of these things that inherently have been late life cycle types of activities? Now, one thing I always mention to people is two things about this. One is, in order to do that, don't think about it as, I need to necessarily complete some of these activities. So for instance, it is true that in order to perform load and performance testing and get valid results that you can use to assess whether your system meets the response time that you need in its deployed environment, or whether things run fast enough. It is true that you have to run those kinds of tests on a production-like environment, because that's where you're going to get statistics and information that look like production. However, that doesn't mean that all the activities involved in load and performance are something you have to wait until you have a production-like environment to run. For instance, you can be monitoring the performance of your code as you increment and change that code, and you can look at performance over time and see whether your application is getting faster or slower. Is it gradually degrading, or is it, as it's growing, all of a sudden becoming much slower? seeing trends like that are things we can measure and assess irrespective of the environment that we're running in. And we can hopefully address those issues earlier in the process. Same can be said about security. Same can be said about compatibility testing and looking at, whether our code that is associated with our UIs, if it's web-based, actually are going to work properly on the variety of browsers and versions that we need to work. So that's shifting left. Shifting right is about the exact opposite, which is slowly moving some testing to the right. Now, when I first heard the term shift right, and it's a little, I'd say newer than the concept of shift left, which I've been hearing for quite a while now, probably at least 5 years, maybe even closer to 10 in some circumstances. Shift right is something that's popped up very recently. And I actually thought it was a joke when I first heard it. Someone was joking that we wanted to move our testing to the right. And that meant kind of going back to, testing being this end of the life cycle thing, right? That we're trying to avoid in DevOps. But that's not what shift right means. What shift right means is there are certain kinds of testing that the best results are results in which we're using production data. And a lot of times early in our process, when we're building it and testing it in various environments, we have data that is mocked or data that is, test data that may or may not reflect our customers. And also there's certain kinds of testing where we can't really mock the data or even use test data because it's really a subjective response from the customer, right? Things like usability is a good example. You need real customers to do usability testing. Otherwise you're not going to know really whether your customers feel your software is usable or not. And that means the best place usually to do those kinds of testing is in production itself, where you've got real customers. And that's about monitoring and measuring and analyzing the things that customers are doing and whether they mean your software meets its quality objectives. And so that's the idea of shifting some of what we're talking about to the right. The last thing I want to mention gets to this idea that testing, while it's a technical activity, is actually for a business purpose, right? I mean, our job and our goal in testing is to provide information. And so continuous testing, as I alluded to in my definition, is also about making sure that we are effectively providing business knowledge and information so that we can make good business decisions. And we should be capturing those metrics and that information and providing it as part of business level dashboards and knowledge bases, excuse me, all during this process so that we know whether customers are using the product right. We've got early metrics on the quality of our code, the security of our code, and we're tracking that stuff over time, again, to see whether software is getting better or if it's getting worse during this whole process. So that's the idea of business value. So to me, kind of to summarize how testing fits into a DevOps world, this idea of continuous testing is about shifting some of our testing to the left so that we are effectively removing kind of late in the process hurdles to pushing code into production rapidly, shifting sometimes to the right so that we can get better test results that rely on our testing being done by actual customers who are giving us their kind of feeling about the software and meeting their needs. It's about doing testing continuously as we go. So we're evaluating and testing all the different artifacts that we have, but also making sure as we make changes, we are very rapidly making sure those changes work the way they're supposed to work. And then last but not least, we're making sure that we're putting testing into a business context, because we want to make sure that it's meeting the needs of the business and that we're providing business level information on risk, on go, no go, on quality and security, compatibility, availability, so we can assess from a business perspective the value and quality of the testing. Now, all of what I'm describing fits into very well the common metrics that DevOps tries to collect, right? If you read the State of the DevOps report, now called Accelerate, it's a free report that comes out every year, you'll see that in there, there's typically 4 common metrics that we're trying to capture, trying to measure the deployment frequency. How often do we deploy new capability to customers? We're trying to measure the speed at which we can make a change and get into production. We're trying to measure how fast, if something in production doesn't work, we can turn it around and get it to work. And last but not least, we're trying to determine how often we deploy something into production that fails. And the nice thing about those metrics, and these are the metrics you should be focusing some of your attention on from a business perspective, is they balance quality and security, which is a key thing I always talk to executives about in terms of DevOps and how testing fits in, is if you just think about DevOps as speed, how fast can I do things, you're gonna just push bad code into production quickly. And so we need to balance it, and how frequently we deploy and how fast we can deploy are kind of the speed metrics. The how fast can we fix a problem that's in quality or in production, and how do we measure and avoid failures in production are our quality metrics. And having all 4 of those and measuring those for business value is a great way to determine are we successfully delivering value to the customer. So let's talk a little bit about Selenified and LambdaTest and how it fits into a continuous testing process. And then we're going to do a quick demo and talk through at least one pipeline and how these products fit into that, and give you some more information on these products as well, and then answer any questions that you all have. So let's start with Selenified. So Selenified is an open source product that we built at Coveris that sits on top of Selenium. It's a Java-based framework that can be used for both UI and API level testing. And the reason we built Selenified, and it was really based on needs from customers, is that there's some things about Selenium that are difficult in a DevOps process. First and foremost, sometimes it can be a challenge to get Selenium properly set up and working within various build environments and CI/CD processes that you want to put automation of your tests into. The second is we often want to do things like compatibility testing and performance testing and things like that. And we'd love for those things to be pre-integrated into a framework instead of having to be added on later. And so it does integrate LambdaTest into Selenified so that you can do compatibility testing across a wide variety of browsers and versions of browsers. And that's something we're going to show and talk more about in the demo. Selenified also provides a lot more detail in its reports and screenshots and traces of the tests that are run so that you can easily diagnose and debug problems if there were failures in your tests. And we'll show a little bit of that during the demo. Now, one thing we wanted to make sure was that Selenified was completely compatible with Selenium, meaning if you had Selenium tests and Selenium information, it was going to be very easy for you to continue to operate and work the way you wanted to for your Selenium-based test. And so all of these Selenium APIs are exposed in Selenified so that you can still run and implement your functional testing or your tests using Selenium. And then last but not least, Selenium often struggles with, when it runs into missing objects or slow page loads of objects. And so you'll get a lot of timeouts and other things in Selenium that really might be false positives for your tests failing. And Selenified tries to address some of that. Obviously, some of those things, you're not quite sure when something is going to actually load or finish, or it's not there at all. So you can't completely solve that problem. But Selenium wraps APIs and tries to better handle those errors and also avoid those errors if possible. So that's kind of at a high level how Selenified is kind of described and defined and how it's used. It is used in a wide variety of organizations. And it's very common that when I'm at one of our conferences at TechWell, that I will run into someone who is using Selenified to do some of their test work. I mentioned compatibility testing, and that's obviously a focus of this webinar. Because if you're going to do compatibility testing, it's a challenge to do that on your local machines, right? A lot of times our applications need to, and we want them to support a wide variety of browsers and browser versions, and it's very hard to scale that on your local machine. The great thing about LambdaTest, and one of the reasons we partner with and integrated it into Selenified, is because it allows us to browse on any platform. And there's no need to set up your own Selenium Grid or your own device farm. We can kind of mitigate the risk of doing compatibility testing and setting up your test configurations, because LambdaTest will do a lot of that for you. And it does it in parallel, right? We want compatibility testing to run fast because we'd like to shift it left, right? Now, depending upon how you think through continuous integration and your regression testing and where regression testing fits into the process, it may dictate where and when and how we're going to perform our compatibility testing. But regardless, we want to tremendously speed it up so we have flexibility on where and when and how it's run. And doing those kinds of tests in parallel can really help you. LambdaTest is set up to do that by running multiple sessions in the cloud. And that's part of the demo that we're going to show today. So let me jump out real quick and jump into Jenkins. But before I do that, let me share a couple of extra slides just to give you some context for the demo that you're going to see. And the demo is going to run longer than this webinar takes to run through everything. So I'm going to kick it off just to show you what the pipeline looks like in action. And then we're going to jump to some results that'll show you what Selenified and LambdaTest look like when they're working together, doing compatibility testing. So this is our CI/CD pipeline that we have set up. The top part is our continuous integration process, and this gets run whenever a change is made. Now, as you're going to see, the application that we're running this on, the demonstration application that we use at Coveris, it's a web-based application. It's got a bunch of different services associated with it. And so if and when any of those services are modified, that particular service goes through its CI process. You can set this pipeline up so that you immediately continuously deploy once a service is updated. And so it will go into the deployment process and go through a wide variety of tests and then get pushed into production. Or you can set it up as what we call a push button capability, where you can basically just do the CI component of it. And then, when you're ready or you've made changes to multiple services, you can then go ahead and deploy into your various testing environments and provide more extensive testing. On the CI side in our demo, what you're going to see is the code is maintained in GitLab. We have a variety of static checks that we're doing as part of our check-in process, both for quality and security, including running find bugs and check style or code standardization, PMD for security. We're then running some unit level, unit tests with code coverage used as a quality gate. And we're also checking to see whether any of our open source components have known vulnerabilities in them. We're using dependency check. If and when you decide then to push into your testing environments for more extensive testing, either automatically as part of your process or on a push button, we then use Docker to create, or we then create immutable Docker images that we can then create Helm charts for that will tell us how to deploy that information and those images into our test environments using Kubernetes. And then we will deploy out and scale as necessary to run the testing that we want to do. We use Selenified for all of that testing at the API and unit level. And you're doing everything from your functional testing like UAT and it might even be manual testing that your testers are doing, to doing other things like leveraging LambdaTest to do your compatibility testing, leveraging things like JMeter to do performance testing, leveraging other tools like Zap maybe to do dynamic security testing and things like that. Now, a lot of people will ask me, well, can you run some of those things back in your CI process? And the answer is yes. It really depends on how fast your CI process needs to be, which we usually advocate. You want to keep your check-in builds to be maybe 10 minutes or less to give feedback to developers. So you want at least your check-in process in CI to be very fast. Now, some folks, as part of their CI process, will periodically run a more extensive regression test that might be nightly, that might be hourly, might be in the cloud, wherever or however it's done. If you're doing more extensive regression testing as part of your CI process, leveraging the cloud, doing things in parallel, there's no reason why you can't incorporate more non-functional requirements like compatibility testing and security and other types of testing into that regression process and be doing those kinds of things every day as your software changes. Now, the application we're going to run is real simple. It's a Node.js application. It basically allows a user to log in, access a database. We're using MongoDB for a variety of different databases that we have established, and access a catalog of training material that's available. And ultimately, goal is for this application to allow you to pick training and do training and maybe attach it to e-learning curriculums and things like that. But it's a web-based application. Each thing is set up as a service. So the UI is a separate component and service. Gateway is used to get to a variety of different services, including accessing the catalog database, user services around user profiles and permissions, and then authentication of the entire system. And last but not least, we are using, as I mentioned, Docker and Kubernetes for this entire framework. And what that really means is that both the code of the services that we are changing and are in our application are Dockerized, and Kubernetes is used to deploy them into testing environments. And the actual CI/CD infrastructure itself is Dockerized, and we're using Kubernetes so that we can scale and speed up the build test process as we need to. So we have dynamic agents for Jenkins that'll do things in parallel as we need it. And we're leveraging tools and capabilities like Docker. We use Nexus repository for our artifact repository. We're using SonarQube for some of the, the quality gates and code analysis and metrics that we want. Well, let me jump in real quick and show you a few things on the demo, and then we'll talk more about LambdaTest and how everything kind of works together. So if I jump into Jenkins, what you're going to see here is a variety of different jobs that relate to the different services that I mentioned. Here's the UI service, here's the authentication service, the catalog service where all the data resides, gateway that's used to communicate between the UI and the services, and then the user services where profiling information exists. And then we have a deployment job, right? Each of these pipelines, as mentioned, are our CI pipelines. So for instance, if I jump into one of these, go into the Angular service and pop into one of our builds and go to Blue Ocean, you'll see what this looks like. And as mentioned, it's a pretty straightforward process we're going to follow, right? I mean, we're going to check out our code, we're going to build it, we're going to be running our CI tests, both our unit tests and testing our libraries to make sure that they are secure. We are going to be then doing static code analysis on our apps using PMD and check style and things like that. And we're going to do some dynamic analysis and both testing and verifying that there's no security vulnerabilities in our web app. We're doing a quality scan as well. And then we're publishing a Docker image. So that's an example of the CI process for one of these services. In this example, the one we really are interested in, though, is the CD component, which is our deployment component. So if I jump into deployment and show you what that typically looks like, and I'm going to jump down actually to one just to give you an idea that failed, because we're going to use this as an example of how everything works in our process as we go. Before we do that, though, I do want to kick off one of these jobs. So we're going to kick off the pipeline so we can get one running. It is going to take a little bit of time to run, but I want to show you a few things in action as it runs. We're going to go ahead and build, schedule a new build to go. If we jump in here, what you'll see in this view is it will start to run. And this is the deployment process into our actual testing environments, and then ultimately, if it passes, into production. And what you'll see is that it's going to check out of the repo, make sure everything works right, and get everything set up. It's going to deploy to our cloud-based QA environment. It's going to run some smoke tests, make sure everything's okay, a quick integration test, functional test to make sure that our APIs and our overall integration works properly. And then we're going to run a series of non-functional tests, including accessibility testing against the UI. And then the other things that happen, you see it just jumped into the deploying and packaging process. Now it's going into its post-deployment checks. And then it's going to run into our non-functionals when it's ready to roll. That will take a few minutes to run. But when it does that, it's going to be doing accessibility, compatibility using LambdaTest, dynamic security testing using ZAP, load testing using JMeter, and performance as well. And then once it successfully passes all those, it's going to go and deploy itself to production. So as that runs, I'm going to jump over and show you a few things in a job that already ran, and then we're going to come back and talk further. Here's an example of the deployment process where we ran these tests and compatibility testing failed, right? So we called LambdaTest, we ran our tests on a variety of various browsers and versions, and we had a failure. If you click on any of these, you can go find out which tests failed. So I can go up to the tests aspect in here, and I'll see I had a couple of tests that didn't succeed, and a whole bunch of them that did. If I go over to artifacts, I can actually dig in, drill into a report, and it'll show me, and this is where Selenified really shines. It'll show you each test that ran. It'll show you what the test was that ran. It'll show you what browser it ran on. And so you'll see that, and this is coordinating with LambdaTest. It's going to show us every browser and every version that we ran. We're doing Chrome 78 on Mojave. We're running it on Windows. So a bunch of Chrome tests here up front. You'll see we've got Firefox, versions of Firefox in here. I can click through and look at some of the others. There's one of our failures right there. And I can see, we've got Safari in here, an unknown browser, which is an interesting one. So So all these will give us an idea of what's working, what's not working, in terms of our testing. Right here. So that's our artifacts. Let me jump back real quick to our deployment process, see how we're doing. All right, it's still running its thing. But we can also not only see the tests as they run, and what you'll see when it gets to compatibility testing here in a bit is it's going to sit and run and wait. Selenified is going to wait for the results to come back from each of these tests, which is great. But for long running tests, we really would like to see more real-time information inside of these various boxes as it runs. And so if we jump over to LambdaTest, over here, one of the things we can do, and we're just going to talk more about the dashboard and how everything works, is we can dive into automation, and it will show us the various builds that have been run in the job that I'm giving you, and show you whether the test passed or failed. And so we can see which versions of the tests worked, which ones didn't, and we can see them in real time. It'll say new data available, and that means that new information has been produced. And you'll see it's running the current build that we just talked about. So it's doing its thing. It tells you that we ran 4 tests so far. I'll show you what those tests are. You see 2 of them have passed, 2 of them are still running. So I can get real-time data about the different tests being run on the different browsers and different things right inside of the LambdaTest dashboard. Now, the last thing I want to show you before I turn it over to Mudit for more information is that if we jump, so there was a problem in this issue, and we saw that we had a couple of errors in that issue. We fixed those errors. They were actually a particular version of a browser, wasn't well supporting current kind of standard for JavaScript. And because of that, it was failing improperly. And we fixed it and we reran it and we came up with this. So now when we look at our artifacts, what we're going to see in our compatibility report is that everything worked now. And one great thing about Selenified is you can look at the steps associated with each pass, whether it passed or failed. So in this case, if I bring up HTML, I can see all the steps for this particular test that was run. I can see the browser that it was run on, what test suite I ran, how many steps were run, right? I've got all this information. And equally important, I can actually view the screenshot of the software at that step and what was happening. So I can, if it fails, I can actually debug and look at it. We can actually do something very similar inside of LambdaTest. If we dive into a particular test, we can see all the information about it. We get a video that shows us kind of, what the steps were and what was happening on the UI as it came up and ran, which is a really cool idea and shows you kind of step by step, what Lambda testing is doing. And you'll see it's coordinating and showing our UI on it as it runs through its tasks. Now, if I jump back here in the automation window, you'll see we're up to 8 tests now that have run. So it's continuing to run and build up across various different browsers that we're talking about. Last but not least, if I go back to our deployment process, you'll see it's still chugging along, getting itself all ready to run and execute. It's going to take a little bit of time. So in the meantime, I'm going to pass it back to Mudit so he can talk more about LambdaTest.
All right. Let me share my screen then. Right, so I think Jeff covered most of the part that I wanted to showcase related to LambdaTest. So The major problem statement that we are solving using LambdaTest is that you get access to browsers and operating systems that you may not have access to locally, so that you have a larger test coverage to run your test on. And the another major advantage of LambdaTest is that you can run your test in parallel. So if you have multiple test threads, you can run them in parallel at our platform, and that will cut down your test execution time by multiple folds. So for example, if you have 100 tests, a build of 100 tests, and each test take 1 minute to complete, running them sequentially will take around 100 minutes to complete. However, if you have, for example, 10 parallel sessions with LambdaTest, you can run 10 tests at the same time. So your overall build execution time will now cut down to only 10 minutes. So you have cut down your overall test execution by a factor of 10, right? And of course, you can run them on all those 100 scripts on 10 different browsers. So you can run 1,000 tests. You get a better browser coverage. You can find out bugs that you may not be able to find out due through exploratory testing or manual testing. And you can be ensured that your all the users, like even the niche users who are using, for example, Internet Explorer or some kind of legacy browser, they are also covered as well, right? And once you have run the test, you get complete logs related to all the tests. So for example, you get complete video execution of the test that is there. You can see the live running of the test. In addition, you get all the command logs. So our platform also takes screenshot after execution of every single command. It automatically takes a screenshot. You don't have to mention in the code. If you are using Selenified, that may not be necessary, because Selenified has it has capabilities to take the screenshots as well. We take a screenshot after every execution of the command. So if, for example, there was some error in any Selenium command during the execution of any Selenium command, you would be able to debug it. Like, this is what the step where the test was not executing as intended. In addition, you also get all the network logs. So all the assets were properly being downloaded, all the JS files, media files, everything, and how long it took to download them. You also get Selenium raw logs. So for example, if you are using any custom based reporting framework that uses Selenium raw logs, this will also help you in that. And you also get access to console logs. So if there was, for example, any error in the console, during the test execution, you will be able to see the console logs as well. So for example, during this execution on Chrome 73, there was an error related to favicon, and it was showing on the console log as well. And you can also check all the metadata, like on which browser the test was run on which operating system, and everything. And all of this is downloadable. You can download it directly from our dashboard as well. Or we also have APIs that you can use to download all this data, extract all this data. You can find it here. We have a help section. We have a very awesome documentation for everything that you can leverage to do this. So we have APIs for everything. So if you want to, for example, extract the videos, extract the test session data, all the logs, screenshots, video logs, command logs, everything can be downloaded, can be extracted using our APIs. So if you are building any custom reporting in your CI/CD pipeline and you do not want to switch over to LambdaTest, you can extract all this data through APIs and use all the assets that are being generated here as well, right? Apart from that, we also have a feature called mark as a bug. So you can integrate with your project management tools. Like if you want, if you're using Jira, you can integrate with Jira and create a ticket directly from LambdaTest to your Jira account. You won't have to switch over. So for example, if there was any error during the Selenium command issue, you can create mark as a bug, and it will open up a pop-up that will allow you to select which project version, etc. you want to send this ticket on. You can also send it to your communication channel like Slack, or if you are using Microsoft Teams, and clicking on create a issue will send this issue along with all the command details along with screenshot directly to your Jira channel, so you won't have to hop on from one platform to another every time. So that's our basic premise of LambdaTest. We are kind of building up a integrated testing solution so that you don't have to hop on from one platform to another. And Selenified kinds of help us in maintaining that you get a complete integrated pipeline that works with just a single click of a button. With a single click, your whole pipeline is connected with each other, talking with each other, and reporting to you at every step. So you don't have to hop on from one platform to another every time to find out what is going on, what is going well, and what is going wrong in somewhere. Right. Another aspect that I would want to highlight would be the names. So everything, for example, which browser to run on, the build name and test name, everything is defined using a desired capabilities object. So whenever you are running your test on a Selenium based grid, you want to define which browser version you want to run your test on, and you define it using a desired capability object. So I want to show you a simple piece of code that I have. It's a simple TestNG script, to-do script. What it does, it opens up a URL, and it's a to-do list with simple clicks and click actions. So the script is not very important. What the important aspect here is to understand the desired capability object and how to run the test on LambdaTest. So if, for example, you already have your Selenium scripts with you right now that are being run locally, if you want to run them on LambdaTest, you need to provide three different changes. One would be that instead of calling a local WebDriver, like calling a local Chrome WebDriver or calling a local Firefox Gecko driver, you would have to call a LambdaTest remote WebDriver. And this LambdaTest remote WebDriver is present at a hub URL. This is the hub URL. And to access this hub URL, you would need an authentication key. So all of this, you can find it in your automation dashboard. So once you log into your automation dashboard, there is a help access key icon here. You can click on it and it will give you your username, access key, and even the hub URL, everything. And that you can leverage here. And the last and the most important aspect would be defining which browser version, operating system you want to run your test on. So this is a desired capability object that you have to define. And in this as well, you can define your build name and test name. So for example, if I want to so this would be really important. For example, if you have multiple builds to test on and you want to see the results of those builds here. So if you have not defined your build name, it would become a little bit difficult to organize your stuff here and find out the relevant test case. However, if you have properly defined your build name and test name here, it will make your life easier in the long run. Right. So let me give you let me just run it very quickly. It's a test in the suite. So a good thing is that you would be able to see it running on LambdaTest platform as well, and you will get a feedback on your console. So even though the test is being executed on LambdaTest, you are getting a feedback on your console as well. So it's not, if you do not want to switch over to LambdaTest platform, that will also work. It won't mean that you would have to always be live on LambdaTest platform. It will work in the backend. And as Jeff also mentioned, you get to see a live execution of that video, live execution of the running of the test. And once the test has been executed, you will see whether the test has passed or failed or completed or not. And as I said, all the logs related to that are also available. So I think the test is still being executed. Yep, it's complete. All the logs are there. Right. So another aspect that I would want to show would be the running these tests in parallel. So I'm using TestNG. So very good example of TestNG is to maintain a suite.xml file to maintain a whole suite. So for example, I have multiple tests. I have test one, I have test two, and I have test three, and I have three tests, and I want to execute them simultaneously. So I'm using parameters to define which browser and operating system I want to run your tests on. And using the suite, I can run multiple tests at the same time. So these are three tests. I'm running them in parallel at LambdaTest. Here it is. So three tests are being run at the same time, and you can see here two are running at one time, and the third test is being added in queue. If I have a parallel concurrency of two here, if I had a parallel concurrency of, let's say, five, all three tests would execute at the same time. And once one of these tests stops executing as completed execution, the third test that is in queue, it will automatically come out of the queue and will start running on the platform like this. Great. So by default, our platform does not understand whether the test has passed or failed, because there are few areas where you want to deliberately fail a test. For example, if you are testing a login screen, you would be deliberately passing values where the test is being failed. So to determine whether so our platform kind of understands whether the test has completed its execution or whether it has failed. But we understand that users want to see the marking a test as passed or failed. So we have defined a JavaScript executor in our test that you can use to define the status of your test, and as an assertion, and you can mark it as an assertion as passed or failed. So if your test has passed completely, you can mark it, assert it as passed, and that using our JavaScript executor, it would be marked here in the dashboard as well as passed. So these are all the main features around LambdaTest that I wanted to cover. Selenified, as Jeff has already covered, it kind of integrates with LambdaTest seamlessly, and using a combination of both makes your whole automation test scripts kind of very easy. So Jeff, is there anything you wanted to cover that we are missing out, or shall we switch over to the question and answers?
No, that was awesome. Great overview of the product. Thank you. The only thing I would mention that I didn't mention was that, and you alluded to the fact that you need to set stuff up in parallel and get everything running, and also define what browsers you want to test against. One nice thing about running LambdaTest through Selenified is through command line parameters, you can describe and define all that in one easy way. So unlike Selenium or anything else where you would be trying to do compatibility testing and you would have to, kind of, orchestrate those jobs, Selenified takes care of that for you and just communicates seamlessly with LambdaTest to make it happen, and just makes it a lot easier to run things in parallel and also describe, what different browsers and versions you want to actually run your tests on. So, I agree, they work really well together. So do you want to move to answering questions, or do you want to cover any other information we need? Are you there?
Right. So I think that's more of it. We can move on to question and answers part, I think. Right. Yes.
Looks like there are some questions in the chat.
So I think the first question is by Candice. Will we be able to download the video for this? So this this webinar is being hosted live on YouTube as well. And after the completion of this, we would be hosting this on YouTube, and I would be happy to share the link to this webinar with everybody else. Right. Uh, is there a course for Selenified itself on, say, for plural site, for example, Jeff?
Yeah, great question. There currently is not, but that's a great idea. We should definitely put together something that describes, how to best use Selenified. If you go to our website, coveris.com, there is information on Selenified and documentation and such that you can use to download, but there's currently no online class for that. But I do think that's a great idea.
Right. Are the Selenified reports something that you need code experience to use?
No, I mean, they're very step by step. They show and describe what happens. Obviously, when you get into the, what happened, why did it fail? You need to know something about the code, but it gives you all the information you need because it shows you the results of each step and even shows you the screens, to at least describe and define the bug, and you can then provide it to someone who does understand the implementation to see what the problem is. But all the information is there.
Right. So would it be possible to run this with Azure DevOps?
So we've done quite a bit of Azure, and I would need to check whether the current version of Selenified is set up and configured to easily integrate with Azure. There's no technical reason why you couldn't do that. I would just need to check and see what the integration is with the Azure DevOps product to be able to see if that currently works or if that's on the futures list.
All right. So this is another question. Will Selenified reports work as an audit paper trail to find out what's being tested, the frequency of pass and fails, and everything like this?
You can certainly do that. Yeah, I mean, there's no reason you can't do that. Now, all the reports are downloadable, and obviously anything you download, you could edit and whatnot. So, I mean, you might want to put some controls around, access to the reports and making sure they are immutable and can't be changed by others. But there's no reason you couldn't use that to kind of demonstrate and verify the testing you did and that you got through the testing requirements that you have.
So in fact, I also want to highlight that Selenified is one of the best frameworks that I came across with out of the box reporting capabilities. So if you're building your own framework, you would have to go with, for example, Maven plugin and build up your own reporting systems. So it's a lot of work to do for that. However, Selenified comes out of the box with a lot of features around reporting and very detailed reporting. So it's one of the best features to switch over to Selenified. And because it's built using Java, you won't be, if you are already used to it, there won't be a lot of a big learning curve. It's easy to understand, easy to use, and there's a very interactive documentation available on it as well. And there's a GitHub repository as well that you can go through to learn more about the framework as well.
Yeah, I see Max responded. So Max works at Coveris. He's the lead author of Selenified, and he mentioned that there is we do have a Selenium course. Go Max for the plug on our course. So we have a Selenium course. It's a 2-day course on test automation using Selenium, and we heavily cover Selenified in that class. It is not a free or online class, but it is certainly something where you do both on site and virtual. And as he mentioned, of course, you need to be able to write code to actually put Selenified in place and kick off the right kinds of things. But from a reporting perspective, the reports are pretty standard. And as he mentioned there, it does work with Azure. There's no reason why it shouldn't.
So another question by Simon, can Lambda test scripts be written in PHP? Of course, so Lambda test is more of a framework or more of an infrastructure that you can use to run your test on. So if you are using any PHP based framework, I think Behat is a PHP based framework, for example, or using vanilla PHP that uses Selenium somehow, you can run them at Lambda test. We have documentation around this as well. So if you go to LambdaTest support, we have extensive documentation around various languages that we support. So PHP is one of them. We also have GitHub repository to help you get started. If you are using any framework like Behat or Laravel Dusk or Codeception, we have documentation around that as well. You can leverage this to get you started with your first test. We will also share this in the YouTube channel and in the mail that we have related to all the attendees. Another question is by someone anonymous. He wants to ask whether we would be able to test internal application that is behind a VPN. So yeah, so that is one of the most important questions that we have been asked. So we have a feature called Lambda Tunnel. So what it does, it's a binary execution file that you can download and run, and it will create a secure shell reverse proxy connection between your system and our system and LambdaTest server. Using this, you can integrate. Using this, you can test your locally hosted or even privately hosted application on the Lambda test platform as well. So we also talked about desired capability object, right? So in the desired capability object, you just have to pass a value here, a capability here as tunnel equal to true, and start a tunnel configuration, and that alone itself will allow you to run your test. So a lot of users may be a little bit want to know more about the desired capability object. So we also have a small utility called capability generator. You can use this utility to create your capability. So for example, if you are using Java and you want to define the tunnel equal to true, you want to test on tunnel, you can just select the options here, and it will all define a capability object for you with tunnel equal to true value. You can define a different browser if you want, and that same would be reflected here in the desired capability object. You can copy this and use this to run your tests. So I think these are our only question. Guys, you are attending. If you have any question, feel free to ask us. We will be happy to answer them. No? All right. I think, Jeff, that's it. It was really nice talking to you. It's really good to know more about your experiences and the way to run continuous testing. We really learned a lot here. Also, we have a question from Candice again. How do we integrate Lambda test with Azure DevOps? So we also have documentations around this as well. I'd be happy to share it with you. So we have documentations around integration with different CI/CD tools. So if you are using Azure, oh, I think we don't have any documentation around this for us right now, but you can certainly integrate Lambda test with Azure DevOps as well. I will help you out with a direct documentation with it, and it can help you get started. Right. Another question that we have: how do we evaluate functional or test coverage? So if you are running any functional tests, the execution of this test is obviously available at the LambdaTest platform along with all the logs, command logs. So this can help you to see what the how the test is being executed. However, the test coverage of your application is something that you have to define, because we don't know what your application is. It's something that you have to define. You have to prepare a plan on all the test cases that you have. All the test cases are being covered via automation tests, and which test cases are being covered manually, because you cannot automate everything. So a few stuff would be left to exploratory testing. So it's up to you how to do that. So if you are running your another question is, so how would I be certain that the page is covered or all the web elements are covered? So again, it's up to you how you define your assertions in your test scripts. If you define like these, all the values are being loaded, you have to define assertions. If you want to, if you do not define your assertions, it won't be easy to find out whether all the elements has been loaded or not. It's up to you how you define your test scripts. You have to kind of find out what all aspects you want to test, and based on that prepare a strategy around your automation testing. So automation testing, Jeff, it's one of the most important aspect people are kind of working on, but I want to highlight that testing aspects is one thing, but planning your automation test is one of the most important thing as well. In fact, it takes a lot of time. You have to define which aspects you want to automate, and based on that, prepare a strategy using which you can finally create your script. So once you have a strategy in place, that will make your life very easy in defining your complete automation test scripts.
Yep, sure does. And I mean, you can link it to tools like Jira or others to get, basically then manage and determine the traceability of your test to particular requirements that you have. I mean, some companies will describe and define their test plans in terms of coverage of their objects or pages, and then link to their test to particular definitions or descriptions of those or mocks of those. As Deek's mentioning, you kind of have to think that through and get, review and make sure your tests cover whatever your criteria is for the testing that you're doing.
Right. So I think we are already 10 minutes over the budget. We are already 10 minutes over our 60-minute mark. So I think we are good to go, good to end here. It was really nice talking to you, Jeff. Really appreciated you walking us through the Selenified framework and talk more about continuous testing. Right. You can know more about Jeff by going to his website, coverus.com. If you want to know more about LambdaTest, you can log into LambdaTest.com, and we also have an in-app chat support. If you want to have any questions, feel free to drop us a ping there, and we would be happy to answer any questions that you have. Right. I think that's it. Thank you guys for joining us. Really appreciate you taking the time, Jeff. Have a great day ahead, everybody.
Yes, thank you very much.